Lesson 1.5, Properties of Numbers. Learn how to identify properties of numbers and use them to simplify numerical expressions. These are great for mental math and things later on when we're dealing with algebra applications. We have 4 different properties that we're going to talk about today in your vocabulary. Let's start with the commutative property. In words, we could say you can add numbers in any order and also multiply numbers in any order. Commutative property does not always work with division and subtraction because order is so important. A way to think about in real life the commutative property, if your parents drive to work somewhere, maybe they drive to Manhattan to work, and then they drive back home that night, it's the same trip, but they just make it in the reverse order. So that's like, a commuter is kind of like a commutative property. I can add 3 plus 8, or I can add 8 plus 3. I'm going to get the same answer either way. Associative property. The example I always use for this is like the football players and the volleyball players. If I wanted to get a total count of football and volleyball players, I can either associate those athletes with the football team and the volleyball team, or if I wanted to get a count by grade level, I would get them all mixed up and I would have the freshmen and the sophomores and the juniors and the seniors. So I've associated them into different groups, but I'm still going to end up with the same total. And again, associative property will only work with addition and multiplication. The identity property, I have 2 different ones. The sum of 0 and any number is the same number, and the product or multiplication of 1 and any number is still that same number. So there's 2 examples there of adding 4 plus 0, it's still going to equal 4, or multiplying 8 times 1, still equal to 8. So let's look at these some examples. Tell which property is represented. So on example A, 2 times 6, that quantity times 1. And on the other side of the equal sign, I've got 2 times the quantity of 6 plus 1. All I've done is I've moved those parentheses and I'm associating different numbers together. I'm still going to end up with the same answer. It's the volleyball football player example. I'm going to use the associative property. For example B, 3 plus 0 still equal to 3. That means that number hasn't changed. It's kept its same identity. So it's the identity property. That's how I keep that one straight. And example C, 7 plus 9 equals 9 plus 7. All I've done is I've taken it and I've rearranged it into a different order. Okay, so it's like commuting to Manhattan and back. Same trip, different order. Commutative property. Couple more. I'm going to do multi-step problems this time and I need to justify each step. So part A, 21 plus 16 plus 9. This is when that mental math comes into play. I can rearrange the order of this so that I've got groupings of 10. If I take this 9 and I move it over to the 21, if I add those together first, I'm going to have something that ends in a 0 or a grouping of 10. So I've rearranged the order, then I'm going to use the associative property to group. 9 plus 21, which I can do mentally in my head, is 30. And then it's easy enough to add the 16 in to get a final total of 46. I could use a calculator, but it's really going to be faster in my head. The next one, again, I'm going to rearrange things here because 5s and 0s, 10s and 5s are always great to work with. So let's rearrange the order using the commutative property. Go ahead and group 5 and 9. If I multiply those, I'm going to get a 0. I could have left it, but associative property, that smaller number first helps. So now I've got 45 times 20, and now I can do this in my head. I can do the 2 times the 45 to get the 90 with a 0 at the end. 900. Okay. Our last property to talk about today is the distributive property. I'm going to use this to multiply numbers mentally by breaking apart one of the numbers and writing it as a sum or a difference. So in numbers, I've got 6 times 9 plus 14. I can break that apart because I can mentally do the 6 times the 9 and the 6 times the 14. Maybe not mentally, but I could write it out really quickly. In the subtraction side of things, it's the same thing. I'm going to take whatever's being multiplied outside of those parentheses and distribute it to each piece and part within the parentheses or grouping symbols. So there's a couple different methods here. 6 times 54, I can either do the addition side of it. I'm going to break 54 into 50 plus 4, and then go ahead and distribute that 6 to each piece and multiply it. That's probably the way most of our brains will work. So 6 times 50, I just do the 6 times the 5 is the 30, add the 0 on. 6 times 4 is 24, add that together. Some of us will think the subtraction side of things. So then I'm going to take 54 and go up to 60. And 60 minus 6 is 54. Use the distributive property to break that apart. 6 times 60 and 6 times 6. So 6 times 6 is 36. Add the 0 onto it. And then I'm going to subtract 36 off. I end up at the same answer of 324, just a different way of thinking. Either method is